When you want to solve an equation, ultimately you're looking for the number that you could substitute into the equation and make it true. And so far, we've only found one number that makes the original equation true. But what can happen is there's an infinite number of numbers that you can plug in and make it true. In other words, you pick any number you want off the number line and substitute it and it's true. And then there are also some equations that no matter what number you select to substitute in, you can't find a single number that makes it true. So we're going to go through the three different scenarios of what happens. The first one is kind of our standard one where we find an answer. And then lastly, we're going to have a couple of examples where no solution, no numbers work, and another one where every single number works. Okay, so starting with this one, remember that when you're solving an equation, you want to simplify each side first. So starting with the left-hand side, the 4 in front of the set of parentheses, it needs to get distributed through. So 4 times W is 4W, and 4 times 1 is 4. I'm going to bring down the plus W, bring down the equal sign. Now this 3 in front of the parentheses needs to get distributed. So 3 times W is 3W, and 3 times -2 is -6. I'm going to bring down the plus 2 on the end. After I've distributed, I want to look to see if there's anything that's alike. And on the left-hand side, I have 4W and W. So we can put those together, and that's going to make 5W. Then I can bring down the 4 that's over here. Okay, then my equal sign. Let's look at the right side. -6 and 2 are on the same side. Those are both numbers, so we can put those together. -6 plus 2 is -4. And then I'm going to bring down the 3W. Okay, now that I've simplified both sides by distributing and combining, I'm going to move all the letters to the same side and the numbers to the other. So I have my W's, my numbers, my W's, my numbers. I'm going to move my letters to the left and my numbers to the right. So I want to get rid of this plus 4. So I'm going to subtract 4. What I do to one side of the equal sign, I do to the other. And at the same time, I'm going to move my W's to the left, and I have a positive 3W, so I'm going to subtract it. What I do to one side, I do to the other. So on the left-hand side, this 4 got rid of that 4, and 5W's minus 3W's is 2W's. Bring down the equal sign. Okay, then this 3W got rid of that 3W, and -4 minus 4 more is -8. Lastly, we can get rid of the number next to the letter because the 2 is what's preventing the W from being by itself. So to get rid of the multiply by 2, I'm going to divide by 2. What I do to one side, I do to the other. The W is by itself, and -8 divided by +2 is -4. Okay, so that's our straightforward solving, but we want to notice what happens when there ends up being no solution or infinitely many solutions. So let's take a look at this example here. It starts off the same. We're trying to simplify each side. So the 6 is going to get run through. 6 times V is 6V, and 6 times 1 is 6. And then I'm going to bring down the -9. And then let's go ahead and bring down the equal sign while we're at it. Okay, the 4 is going to go through, so 4 times V is 4V, and 4 times -1 is -4. And then I'm going to bring down the 2V. We're going to continue simplifying, and on the left side, V's, numbers, numbers. I can put these numbers together because they're on the same side. So 6 minus 9 is -3. And then I'm going to bring down the 6V. Okay, let's bring down the equal sign. On the right side, we have 4V and 2V, so those can go together, and that makes 6V. And then we still have this -4. Okay, so now this is where all of a sudden something happens. We go to move letters to one side, numbers to the other. So if I want to move all the V's to the same side, I'd subtract 6V. And what I do to one side, I do to the other. But what just happened that's different? When I subtract 6V, see how the V's drop out? And so all I have left on the right side is the number -4. I bring down the equal sign. When I subtracted 6 V's, the V's dropped out on the left also. And all I have left is -3. So you know that you're dealing with a special case when all the letters drop out. Now specifically, what we have left here is not a true statement. The number -3 does not equal -4. So there's two things. The first one is all the variables drop out, so I know I have a special case. But the second thing is what's left over is not a true statement. That's what tells me that there's no solution. No matter what number I try to substitute back into the original, there is not a number out there that will make this true. Okay, so now we're going to look at one more that has the other special case, but just a preview. In both special cases, all the variables drop out. But in this one, we were left with a false statement because -3 is not -4. Okay, so here we go on this one. We go to simplify each side, so the number 5 gets distributed. 5 times y is 5y, and 5 times 1 is 5. I'm going to bring down the -y, bring down the equal sign. Okay, the 4 gets distributed, so 4 times y is 4y, and 4 times -1 is -4. Let's go ahead and bring down the +9. Now that we've done the distributive property on both sides, we're looking for any terms that are alike on the same side to combine. And on the left side, I have 5y and a -1y. So these two are like terms, so I can put those together. 5y's minus 1y is 4y. And then I'm going to bring down the +5. Okay, then I'm going to bring down my equal sign. On the right side, what we have that are alike is the -4 and the +9. So -4 plus 9 is 5. And then I'm going to bring down the 4y. Okay, and this is where it gets more interesting. I start to move all the letters to one side, numbers to the other. So to move the letters over, to get rid of a +4y, I'm going to subtract 4y. What I do to one side, I do to the other. And notice when I subtract 4y, all the y's are gone. And I have 5 left over. And on the left side, when I subtract 4y, all the y's are gone on the left also. And what I have is 5. Now what's the same about this one is all the variables dropped out. So I know it's a special case. But what's different is what we have left over is true. The number 5 does equal 5. So that tells me that there's an infinite number of answers. All real numbers are solutions. In other words, no matter what number I pick off the number line and I put it back into the original, it's going to make a true statement.